Alrighty everyone, so today I will be going over discrete probability again, but today I'll be covering mean, variance and standard deviation in discrete probability. So let's start off by knowing what mean is. Well, mean is the average of the dataset which gives us the center of probability distribution. So this is exactly what mean is going to be. So this center line over here is going to be your mean. And this is denoted by EX or mu, so this can also be written as EX and also be written as mu. So mu is just this symbol over here, mu. And now this is the formula to calculate mean in discrete probability. So let's start off by doing this question. I'll explain this formula of mean as I do this question below. So first of all, we will find the value of k given our probability mass function. Well, this is kind of a cliche task by this point, I hope. All we have to do is to add these numbers up and make it equals to 1. Well, because all the probability add up to 1. So it's going to be 1 on 3 plus 1 on 2 plus k equals to 1. And that would make 5 on 6 plus k equals to 1. Implying that k equals to 1 on 6. Where are your 2 marks? Well, 1 mark for knowing that all the probability adds up to 1 for constructing this equation basically. The other mark is for the right answer. Alright, find the mean then. Okay, so let's learn what this mean formula has to say. So this symbol over here is also called sum. Basically it's just sum of x times PR of x plus x. So this x over here is this right here, and this whole thing over here is this. So how to calculate mean? The basic gist of it is we times 1 by 1/3 plus 2 times it by 1/2 plus 3 times by k, which is 1 on 6, and so on and so forth. So EX is going to be 1 times 1 on 3 plus 2 times 1 on 2 plus 3 times 1 on 6. After simplifying all that, you'll get an answer of 11 over 6. Alright, now we are given this question number 2 here again, where we have probability mass function, and we are meant to find E of 3x plus 9. So as you can see, there's like a translation and dilation applied to EX over here. So how do we tackle these sort of questions? Well, what we can do is just simply, so this x over here, this one over here, and here, they are the same thing. They are no different. So how does that make our life easier? Well, what we can do to find E of 3x plus 9 is just substitute 1, 2, 3 and 4 in terms of x, and then times it like we did for this question over here. But let me just show you. So 3 times 1 plus 9, so this 1 come from here, just substituted it in place of x, and then times the whole thing by 0.2 plus 3 times 2 plus 9 times the whole thing by 0.32 plus 3 times 3 plus 9, and then times the whole thing by 0.16 plus 3 times 4 plus 9, and times it by 0.32. Now after simplifying this, you would get an answer of 16.8. Now don't worry, VCA exam numbers would be a bit more friendly, because all of these questions I'm doing are like exam 1 questions, so they'll make sure that the numbers are not too hard for you to work with. Alright, now E of x squared plus 1, how do I find that? Well, again, all we do is just simply substitute 1, 2, 3 and 4 in terms of x and then find it. So E of x squared plus 1 is going to be 1 squared plus 1 times 0.2. So again, this 1 square, this 1 comes over from here again. So yeah, and plus 2 square plus 1 times 0.32 plus 3 square plus 1 times 0.16 plus 4 squared plus 1 times 0.32, and this would give you an answer of 9.04. and there you go. That's how we do these sort of questions. Now here's a conceptual question. Is there an easier way to calculate mean in questions involving linear transformation? So question like this, where there's a dilation and translation applied, is there an easier way? Can we derive an identity to make our lives a bit more easier? Well, of course we can. So if f of x is equals to ax plus b, which is a linear function over here, we have to find E of ax plus b. Okay, we know that formula of E of x equals to sum of x times probability of x equals to x. Now, this x over here and this x over here, they are exactly the same. There is no different. And this part over here, it can also be called p of x. They all mean the same thing. So rather than writing pr of x equals to x here, I can also say p of x. Exactly the same thing, no different whatsoever. Alright, what I'm gonna do is substitute this as p of x. So next step is again sum of x times p of x. Right? Now, if you realize that if e of x, if you have to find mean of e of x, we have x here. Then what happens if you have to find mean of e of f of x? Well, we just substitute what's inside this bracket over here. So here we just substitute f of x instead of x, because this x is the x over here. So whatever is inside the bracket, we simply substitute that in the formula, times it by p of x. That's our next step done. Now, the following step is just substituting f of x equals to ax plus b. So ax plus b, and then times the whole thing by p of x. Now what I'm going to do, I'm going to expand this expression over here, and this would be sum of ax times p of x plus sum of b times p of x. Again, what I've done is just simply expanded. It's nothing fancy. Alright, now next thing I'm going to do is to take out a as common. So a times sum of x plus p of x plus, here I'm going to take b out as common, b times sum of p of x. And now this formula right over here, doesn't that look a lot like this one right over here? Well, yeah, exactly. It's the same formula as to calculate mean. So this is just going to be a times e of x plus b. Now where did this term go? Well, this is basically what this basically saying, sum of all the p of x, which is just going to be what? 1, because px is what essentially? It's just probability function, probability values, and all the probability adds up to 1. So our final answer for e of ax plus b is going to be a times e of x plus b. There you go, that's your linear identity derived. Now, this identity only works for questions involving linear transformation. So, it only works for questions involving this and not anything which is other than linear. So, this won't work for x squared. It will work for this one, but it won't work for x squared plus 1 because that's not linear, obviously. Now, next question. Use the identity you found in the conceptual question and then try question 2a again. So instead of using the substitution method like we did here where we substitute 1 and then times it by 3x plus 9 and all that crap, what we do is just use this identity. Well, now we know that e of ax plus b is just going to be a times ex plus b, right? So e of 3x plus 9 is going to be 3 times e of x plus 9. Now, rather than substituting vigorously to find our answer, what we can do is just calculate the mean like we do every single time. We just calculate the normal e of x. How do we do that? Well, e of x is going to be 1 times 0.2 plus 2 times 0.32 plus 3 times 0.16 plus 4 times 0.32, and that would give you an answer of 2.6. Now we simply substitute that in, so e of 3x plus 9 is going to be 3 times 2.6 plus 9, which is going to be 16.8. So as you can see, same answer as the method we did before. So this identity can make your life a lot easier sometimes when the numbers look messy, like who is going to bother doing 22x plus 101? No, I'm not going to be bothered doing that. So you can just simply find the mean and then apply the linear transformation formula. Done and dusted. So that's all for mean. Let's move on to variance. Alrighty, so let's now look at variance. So variance is the measure of how wide or narrow the spread is. It is also used to determine the consistency of the dataset, and it is denoted by VAR of x and has a formula of this right over here. So I'm going to explain what variance is by using this example down here. So Daniel and Rahul are competing for the SAC scores, the highest method SAC scores. The table below shows their scores for 3 sacks in method. Okay, draw a bell curve for both students based on their scores. So a bell curve is, what is a bell curve? Well, again, it just looks simply like a bell. So this is like a bell curve. And let's say that we are drawing Rahul's bell curve over here. So this is going to be the mean, and Rahul's bell curve is going to be like a bit more spread as I've drawn here, because his scores are kind of like all over the place. Now let's draw Daniel's one. So Daniel 1, so it's just going to be like a, not like that, so it's just going to like a very narrow bell curve over here, as you can see, compared to Rahul. Why? Because Daniel's scores are just, you know, right next to each other, and they are quite consistent. So that's what variance is used for. Now, using the bell curve from part A, identify which student is more consistent. So this student, obviously, so Daniel is a bit more consistent than Rahul, so answer is going to be Daniel. Hence, identify the relationship between bell curve and the variance. So the relationship that we can determine from this bell curve example is the wider the curve, the higher the variance, and the narrower the curve, the lower the variance. As you can see from this example over here, because Rahul's scores are all over the place, his spread is going to be quite big compared to Daniel's one, who is a bit more consistent with his scores, and is going to be quite, the variance is going to be quite small there. Alright, now can we express this variance formula in any other format? Well, yes, because this formula at the moment is quite unusable, in a sense that not many questions give us the information to calculate variance using this formula. So what I'm going to do is I'm going to derive another expression which is going to be also in your textbook. So I'm going to expand this term in the center firstly. So e of x squared minus 2 mu of x plus mu square. And there you go, that's the expansion done. I've just applied quadratic expansion rules here, nothing else. And now what I'm going to do is I'm going to split this whole term into 3 smaller terms. So e of x squared minus e of 2 mu of x plus e of mu squared. The next step, again, I'm going to simplify this further by bringing 2 mu out as a common factor. Well, not common factor, but as we already saw before in the linear transformation formula derivation for mean, that we can take the things out of the bracket as long as they are linear, and this term is going to be linear, right? So 2 mu is going to be out of the bracket times e of x plus mu square. Okay, now we know that e of x is equals to mu, right? They're the same thing, just different syntax. So we can substitute that in here. So e of x squared minus 2 mu times mu plus mu square, which is equals to e of x squared minus 2 mu square plus mu square, and that is going to be e of x squared minus mu square. And now I'm going to substitute back e of x again instead of writing mu, so that our final equation is going to be e of x squared minus e of x to the power of 2. And there you go. This is another way we can also calculate variance in discrete probability, which is a lot more feasible, because we can easily find e of x squared and also the mean and then square it. That is a lot more easier than applying this formula over here. It's a lot more convenient. So we can express variance also as e of x squared minus e of x whole square. Alright, now another conceptual question: is there a linear transformation identity for variance like we had for mean? Yes, there is. So I'm going to quickly derive that by explaining that to you as well. So variance of x we calculated here was e of x squared minus e of x whole squared. Now what I'm going to do is I'm going to substitute variance of f of x is going to be e of f of x squared minus e of f of x whole squared. Right? All I did was just substitute f of x. Now I'm going to again write this in terms of a and b. So ax plus b equals to e of ax plus b whole squared minus e of ax plus b whole squared. Okay, again we can simplify this further. E of ax plus b squared minus, what we can now do is write this as a times e of x plus b as we derived before. This is just a linear transformation formula for mean, so, and then square the whole thing. Now I'm going to expand this term over here. Again, I'm going to split this into small terms now, smaller terms. So now again I'm going to split this whole thing again, so we can write this as, alright, now we can cancel some terms out after next line. So wait, we're almost there. So what we can now do is cancel this one and this one out, because e of b squared is just going to be b squared. Why? Because, well, e of 3 squared is just going to be 3 squared, which is equal to 9, right? So same logic. Alright, we can cancel these two out. Now what we are left, we can also cancel these and this out. Now what we are left with is a squared e of x squared minus a squared e of x whole squared. And again we can take out a squared as common factor, e of x squared minus e of x whole squared. And this formula looks exactly the same as what we derived further, which is also the variance. Well, there's no b over here, there's no plus b over here. And why is that? Well, to make intuitive sense of it, b is the translation. And what does variance do? It just controls the spread, meaning the dilation of the bell curve. It has nothing to do with translation. So that's why there is no b in this identity. So there you go, that's your variance identity derived. Okay. Exam style questions. Calculate this when PMF is given. Okay, pretty easy now, hopefully. So e of 5x plus 2 is going to be 5 e of x plus 2. And let's simply calculate the mean, 0.4, which is going to be equals to 2.7. And just sub it in. So 5x plus 2 is going to be 5 times 2.7 plus 2, which is going to be 15.5. And there you go, that's your mean calculated. Now we have to calculate variance. Well, variance is also, we can just use linear identity because these are all linear transformation, and we can normally ask linear transformation anyways in both exam 1 and exam 2. So all of this x squared plus 1, they are quite uncommon, quite rare. So most common ones are just linear transformation. So feel free to use this identity. So variance of 2x plus 8 equals to 2 squared times variance of x, which is equals to 4 times variance of x. Now let's calculate the variance of x. So variance of x is equals to e of x squared minus mean squared. So that is going to be, how do I calculate e of x squared? Well, you should all know by now, which is going to give you 8.9. Now variance is equals to 8.9 minus 2.7 squared, which is going to be 1.61. So variance of 2x plus 8, which is equals to 4 times variance of x, which is equals to 4 times 1.61, which is going to be equals to 6.44, and that's your variance of 2x plus 8. Alright, given that variance is 5 and ex squared is 17, find the mean of the dataset. So we know that variance equals to e of x squared minus e x whole squared. Now we know that variance is 5, which is equals to 17, minus e of x squared, which is equals to 12, equals to e of x whole squared. E of x is just mean again. So e of x, the mean is just going to be square root of 12, which is going to be 2 root 3. So therefore, e of x is going to be 2 root 3. And there you go. That's how you do this question. So, okay, sorry. Where are the marks at? Okay, yeah. So marks is going to be, for this question, for 1 mark for calculating this, 1 mark actually for the whole thing over here, and then the second mark is for the correct answer. Now the mark over here, same thing. We can say that 1 mark for correctly doing this step over here, and then 1 mark basically for doing all of the method working out correctly, and then the 1 mark for the correct answer. And there you go, those are your 2 marks. And here, realizing we have to use this formula and the answer. So okay, whenever you put down a formula, make sure you put numbers into there. So I would give 1 mark to this, not this here. This is just formula, so no. What I would give 1 mark to is this over here, and then the final answer. Alright, so these are your marking scheme. Okay, let's now move on to standard deviation. Alrighty, so let's now look at standard deviation. So standard deviation also measures the spread of probability distribution, just like variance, but it shows us how far the results are from the mean. So similar thing to what variance does. So here's an example. So let's say you have this bell curve, and this is your mean. Well, there's 1 standard deviation, 2 standard deviation, 3 standard deviation, so on and so forth. It shows us how far, so it shows us how far the results are from the mean, where this is mean. So that's what standard deviation is. So this is 1 standard deviation away, this is 2 standard deviation away, this is 3 standard deviation away, and so on and so forth. Alright, so this symbol right over here is called sigma, sigma, to represent standard deviation. And standard deviation is also the square root of variance. So using this knowledge, can we derive a linear identity, a linear transformation identity for standard deviation? Of course we can. So how do I do that? Well, we know that standard deviation of ax plus b is going to be variance of ax plus b, right? It's just same from here. Now, what was variance of ax plus b that we calculated before? It was a square times variance of x. So standard deviation of ax plus b is going to be square root of a square times variance of x. Now that would simplify to modulus of a times square root of variance of x. Now this part over here, the modulus of a part is kind of like a specialist stuff. But whenever you remove a number from the square root, like I did with a, so a square and then square root it will give you mod of a. It's like similar to how methods has x modulus of x, which is equals to like x square root of x square. It's the same logic. So square root of a square is equals to just mod of a, stuff like that. So same logic. But yeah, this is like more sort of specialist math stuff than methods, but just keep this in mind. We are just deriving the linear identity to help you out further. So standard deviation of ax plus b, the final answer would be modulus of a times, and this square root of variance x is just going to be what? Standard deviation of x as shown here. So this would just result in standard deviation of x, and there you go, that's your linear identity for standard deviation. Again, why is there no b? Well, because again, standard deviation controls or measures the spread just like variance. It has no connection with what kind of vertical translation is applied. It just measures the dilation or the spread of the bell curve. So how do I use this identity? Well, what does this mod mean? Well, let's say that you had to write negative 5x plus 9 using this identity here. So that we can write this as negative 5, mod of negative 5 times standard deviation of x. And mod of negative 5 is just going to be 5. So 5 times standard deviation of x. So whatever number is inside a modulus, no matter if it's negative or positive, it is always positive when you take out from the modulus. So if I were to write mod of 5 is going to be 5, modulus of negative 5 is still going to be 5. So and so on and so forth. So just remember, it's going to be positive all the time regardless of what the sign is of a. Okay, now let's do this exam style question. So given that variance of 2x plus 9 is equals to 16, calculate standard deviation of x. Okay, variance of 2x plus 9, if you were to use the linear identity for variance, is going to be 4 times the variance of x. Now 4 times the variance of x is going to be 16. So variance of x is going to be 4, and standard deviation is the square root of variance, right? So that would just mean that standard deviation is going to be square root of 4. Therefore, standard deviation is going to be 2. There you go. And where are your 2 marks? Well, 1 entire mark for working out, and the other part is just the correct answer. So 1 mark for this and 1 mark for using the correct method. And there you go. So that's your 2 marks. So this has to be like a 2-marker question. I just explained what the marking scheme is. Okay. Again, we are given this probability mass function table. This has to be pretty much the most easiest thing that you will, this has to be pretty much the most easiest marks, like a free marks to you in VCA exam 1. We have done so many of this that by now, hopefully, you should be fine with these. Alright, so for finding standard deviation, well, what we need to first know is variance. Now, how do I find variance? We know that variance equals to e of x squared minus e of x whole squared. So our variance, which is equals to ex squared minus ex whole squared, is going to be 2.2 minus 1.2, which is equals to 1. So variance is just going to be 1, and standard deviation we know is the square root of variance, which is equals to square root of 1, which is going to be 1. So standard deviation is just going to be 1. There you go. So this is how you find standard deviation using a probability mass function. Okay, now time to do the final exam question, where I combine all the knowledge of discrete probability that I taught you so far and put the whole chunk into one question. Okay, so we are given this probability mass function table over here. So x is a random discrete variable, and where k is a constant. Okay, find the values of k, value or values of k. Now, how do I find values of k? Pretty easy. All of this we know that add up to 1. Now, are both values acceptable? Let's look at probability distribution table here. Are both of the k values acceptable? No. K equals to -1. If I were to substitute k equals to -1 in this term over here, wouldn't that give me a negative probability? Right? So we have to mention that k cannot be equals to -1. Okay, so our k value final answer is going to be 2 on 7. So there you go, that's your first question done and dusted. Where are your 3 marks? So well, 1 mark for all the working out that you do. So all of this is 1 mark, regardless of what the numbers are, but hopefully you should get them correct. Now the second mark is to find both of these values of k, and third mark is going to be, actually the second mark is going to be this part over here, where you find both values of k and reject one, and this is going to be our final mark, where you tell them that this is going to be the value of k, and that's all for this 3-marker question. Okay, be careful with all of this because they often trip you up with that, so just be on the lookout for these sort of small tricks and traps where you fall into. Okay, find median and mode. Find median and mode. Well, this is going to be a pretty hectic task, right? To find median, we have to substitute the value of k in to get the values of probability over this and this. Well, no. The method is a lot more simpler than that. Well, how can we do that? So, this is going to be 30%. We know that, right? Now, look at this equation right over here, the one that I circled. This tells us that these two, when added together, is going to be 0.2, meaning that this is going to be 20%. Now, if I were to add these two up, we'll get 50% straight away. So, just by this, we know that our median is going to be somewhere over here, right between 3 and 4, right? Now, this would not be the case if I were to move 0.5k over here and take 0.5 over here. The problem here is, you can see that 0.5 already shifted here, meaning that 0.5 plus this value, if we substitute k, would give us a number that is greater than 50%, so 0.55 let's say. And that would change the median entirely. That would mean that median would lie somewhere between 2 and 3, so between these two boundaries of 2, right? So be careful. In this case, we are lucky enough that we get them side by side, so we can easily tell that these two when added up will just be 20%. So we can easily tell that median is going to be 3 plus 4 over 2, which is equals to 3.5. If you're confused how to find median and stuff using this probability, this mass function, well, just visit my part 1 of discrete probability. I go through this stuff in quite detail there. And how about mode? Well, mode, you can see, is just going to be the one with the most probability, so 4. See how easy that was? Yeah. So 1 mark for correct answer and the other mark also for correct answer. There you go. That's how you do this question. Now calculate the mean. So mean is going to be a hard task for you to do considering the numbers and how messy they are. But in Vika they will give you numbers that are better for you to use, so it will save a lot of time. So don't worry about that. That's your mean. How do I find variance? Pretty cliche stuff by now, I hope. So variance is going to be ex squared minus e of x whole squared. And standard deviation, very simple. And where are your 2 marks? Well, 1 mark for finding this value and this value, and the other for just correct answer. That's your marking scheme. So how do we find standard deviation? Well, very simple. Square root of variance, which is just going to be square root of 8.01. Therefore, standard deviation of x is going to be 2.83. Let a equals to 3x plus 5 and b equals to 6x minus 1, where a and b are both random discrete variables. So we have introduced another variable. So now we have to find probability that a, which is 3x plus 5, is greater than b, so 6x minus 1. And just solve for the inequality. So probability of minus 3x is greater than minus 6, meaning probability of x is less than 2. And that is just going to be, let's look at our PMF over here. So less than 2, everything less than 2 is just going to be 0.3. Alright, so that is going to be 0.3. And last question, so probability that x is less than b, which is 6x minus 1. So solving the inequality would give us probability of negative 5x less than negative 1. And this would result in probability of x is greater than 1 over 5. Now x is greater than 1 over 5 is just basically saying x is greater than, x is greater than 0. That's basically what it's saying, because 1 over 5 is like a decimal, so x has to be greater than 0, which is just going to be that's your entire discrete probability done and dusted. I hope you liked this video and found it useful. Hope you learned something from it. For now, this is it. I'll see you in the next one. Bye bye.